Hello.
How's it going?
Good, good. Are you playing drums? Is that a drum kit behind you?
Yeah, I do have a drum. It's not set up, but yeah.
Nice.
Do you play at all?
Used to play the guitar, but that's it. Not too much of a musician. I think it's better for everyone if I don't play.
Fair enough.
Guys.
Hello.
Hello.
How was composite working group?
Good, good. The implementation is coming on quite well. Now we figure out the last bits and pieces. The specification is still a lot of work, as always. Like that's a thing,
like a-
yeah, where you what is, I would say, the most important part of it, but where you get to last. Like because you first, like we've written so many parts of the specification, and then someone starts to implement it, and at the moment someone types the first two lines of code, they're just like, well, actually, that
That
will never
doesn't click.
happen, you know?
I'm
So
curious if you have like a rough timeline of when you kind of expect it to be picked up by, you know, like the libraries and the frameworks to kind of start
so
using. Because I
with Hot Chocolate, we already are quite far along with the implementation. So our implementation will be mostly ready by conf. So we actually have a talk where we like have a getting started with it. So just that you get the feeling of how it compares to Federation and so on.
right.
We aimed initially for having the specification in one of the draft states by the conf, but I'm not sure if we're gonna make it because we are so busy with all the other things that we have to prepare for the conference. So
I
yeah.
may reach out to you actually ad hoc because I think I might be giving a talk at the conf about like this like weird edge case with Federation as it relates to um kind of like losing asynchronicity, but it might be solved with the composite schema spec. Um, and so I want to make sure I'm like pitching what I'm saying in terms of like, well, this will be solved with the composite schema spec, like with the like lookup directive. So um,
Yeah, most of it,
What?
like most things will be solved. Most the ugly parts are solved. There's a good blog post by Uber staff engineer that a bit lined out the issues that they have with Federation, and he already said he thinks it's partially solved with the composite schema spec, but he didn't know about the batching mechanisms that we have, right?
I wrote up the specific thing that I am running into in the composite schemas -WG channel in the Discord. I
And
think
Oh
the
yeah,
second I think the
Wait,
second one is solved with lookup, but the first one maybe not. Um,
do you have Slack?
do you have
sorry?
Slack?
Do you have
Slack?
Oh,
Slack?
I
We are
have.
all on Slack. Also, the
Because
Apollo guys.
we have built a shadow IT, you know.
Okay, I'm in the GraphQL Slack.
No, not in
Uh,
this Slack. We can invite you.
Can you
okay,
send
yeah,
your email
I
address and we
Uh, it,
can add you to
it's a
it?
federated Slack,
Yeah, it's a it's
a
a large.
composite Slack.
It's all the GraphQL
okay.
companies basically did. How do you call it in Slack? The this company connect.
Yeah, my
Slack
company
Connect.
has that, so I guess yeah, my company has Slack, so I think I can convince the IT admins to
Yeah, we can
Yeah,
plug you
add
in.
us to that. Okay,
yeah.
yeah, I'd
It's
appreciate that because I definitely want to make sure that what I'm saying at the conference isn't immediately then going to be like, okay, that guy doesn't know what he's talking about. Just ignore him. You know what I mean? So
we
I'll run it by you.
we can also set up a call later. Actually, later this week is gonna be hard, but next week where we can chat about things if you want.
Yeah, I'd really appreciate that. Thank you.
Yeah, that's
And
fine.
then, as I said, as a sneak peek until we get the Slack thing set up, you can check the composite scheme of the working group channel in Discord, and yeah, you can see what I'm
Yeah.
talking about there.
Yeah, it's 32 people in this Slack. Like
Well, 33.
In which one?
in the
in-
composite schema work group.
Just in the composite schema. Yeah.
Yeah.
Yeah, we have a couple of channels. So there is the GraphQL community leader channel. It's even bigger.
It's even
right?
more, 46 people in
No,
there.
46. 46, yeah. But from different companies, like from Netflix, from everywhere. It's federated. Federated Slack.
Are we too early, or is there a colliding meeting?
Could probably ping Lee. I think he's on the agenda, right?
Yeah, I thought so. I mean, he's the host.
It's
He's-
Yeah,
GPT-5 day. Maybe got held up. I don't
Oh,
know.
is it? Is it
Oh, are they
GPT-5
releasing?
day? Nice.
Or maybe he
GPT-5 will
tried
be
to.
in this meeting from now on.
Try it in ChatGPT. Great. Not available in Europe.
Really? No. Really?
No GPT-5 for us, guys.
Whoa. Why?
Let's wait for the benchmarks. I mean, it's great to release this on a Thursday, because then I know on Monday if I still need to go to work or not, you know. If all the problems are solved now, then just a few agents and
Artificial GraphQL intelligence is finally here.
I mean, I'm still absolutely flabbergasted about the move that Apple pulled off with Apple Intelligence. When I watched the presentation and they came with AI, and I was like, oh, the Apple AI feature, and then it was Apple Intelligence, and I was like, no way. It's such a genius move. So Apple.
Apollo GraphQL intelligence.
Yeah. Apollo Intelligence.
It fits.
You can have that one for free. If you need any more marketing ideas.
Yes. So are we talking about nullability, Mark, today? I mean, since you're here.
Well, the only real agenda item, I think, is schema coordinates, right?
Oh, schema coordinates.
But I think it's kind of only to give the final blessing.
Oh yeah,
don't
you're
really know
working
what I
from. I
yeah,
think it's
like
3
we
years.
gave a bunch of
3, 4.
well, yeah, I took some time off working on it because like it didn't really need working on, but then the stat cut was coming around, and so Martin was like, hey, we should get this in. So thank you, Martin, for pushing me on this. I don't know if at this point it's still going to make the stat cut or not, but I did make the changes this is for the recording, so highly if you watch the recording, I made the changes as suggested. There's a implementation change as well linked in the PR. I think again it's kind of as good as I can put out, but definitely would welcome Benji's URIs on it to make sure it jives with kind of what you were saying, what you had in mind. Yeah, that's it. I guess just as a summary for people who haven't been following along on the schema coordinates drama, we'll just kind of like
I mean, we
reduce
use it for forever now. The schema coordinates.
it is what it is, right? The changes that I made were just kind of like reducing the scope of, instead of using the full set of tokens and having like an if statement to be like if schema coordinates don't include ignore tokens, just define schema coordinates with their own grammar with a restricted subset of tokens and give it its own Lexa class, and reduce the changes needed in the spec to account for dot versus triple dot versus double dots or whatever. So Yeah. All right.
But it seems like maybe ChatGPT 5 is coming soon. Like as a host. Lee is not coming, so.
Let me check it.
But there is, I thought there's just one GPT-5, but I'm reading now there are again 3.
There's only one GPT-5 for you to use, but if you want to integrate your LLM, then it's just too expensive.
It's just mini and nano also.
Grande, Venti.
Yeah. Benji was also not online, I think.
No, Banshee is also not on the agenda.
No, he's off. Yeah, I see that on Slack.
I'm happy to keep talking about the composite schema stuff if there's nothing else on the agenda.
Yeah.
And
If you want.
Yeah. Should we start at this point? Should someone just take over the host, or what's the usual procedure when the host doesn't host?
Venti equals GPT-2. 20.
By definition. I nominate somebody from the TSC to host. So
Yeah,
Michael and Marta.
it's just 1 second. 1 second. I was not suspecting this, so let me quickly pull up the agenda. Just okay. Quickly share. Okay, let's get started. Hi, everyone. Let me remind you that by being here in the meeting, we all agree to the GraphQL Spec membership agreement, the participation guidelines, the contribution guide, and the GraphQL Foundation Code of Conduct. Also, these meetings are recorded and published to YouTube, so if you don't agree with that, please disconnect. We also use LLMs, AIs to do summaries, so just that you are aware of this. Let's start with a quick round of introduction. My name is Michael, and I'm the host today.
Mark, you're next.
sorry. Yes. Hi, Mark from Yelp.
Hello, everyone. Martin from Apollo.
Pascal from Chili Cream.
And
Hello,
I'm
Ion.
Benoit. Sorry, Benoit from Apollo.
And I'm Jeff from Apollo.
Awesome. Let's have a look at our agenda. We have one thing on them. I'm not going through the agenda items. We leave them for next time. And we have here schema coordinates. If you want to take us through. Let me just 1 second. And you can have the control.
Okay. Yeah, I kind of, I guess I already said it earlier, but just for the record again, so schema coordinates have been in progress for a while. The last meeting, Lee suggested reducing the scope of the implementation, and instead of having an if statement in the vector class to be like if schema coordinates ignored tokens. And then there also had to be some changes to the spec to disambiguate punctuators to account for like the full stop token in schema coordinates to disambiguate it against the fragment spreads and stuff. So, but now if we just define schema coordinates to have its own grammar with a reduced set of tokens, it does not include any of the ignored tokens. or fragment spread syntax, then that becomes a lot simpler. So the spec change is reduced. It's just its own little thing with its own little grammar, and the implementation has its own separate Lexa and parser class now. So yeah, it does simplify quite a lot, and no changes to the actual formats of schema coordinates. I think that's pretty ironclad now. So yeah, I guess I'm happy with it. I think I'm sure Benji/Lee will want to maybe tweak the wording or something like that. But I think the meat and bones of it are there.
Yeah, and the good thing is that this stayed the same. There was some suggestion around changing this, the enum values. But
right, yeah. At one point was going to be like the hashtag, and then we reverted back to full stops. So yeah, it's been quite a lot of bike shedding on that one, but I think it is what it is now.
Okay, and this is already accepted. It's just basically edits.
Yeah, just I would say in the grand scheme of things, relatively minor edits. Yeah.
Awesome.
And again, thank you to Martin for pushing me on all of this, and Benji and Lee.
Thank you for doing everything, like all the heavy lifting.
Yeah, well, and I like to extend that thanks to Benji and Lee as well for rewriting quite a lot of it. So. Oh, actually, there is one thing that is still lingering as a to-do. Now I remember. So again, for the recording, this is an open question. I don't know if this blocks the spec change going out or not, but we talked about having the dot get schema coordinate method or the dot coordinate attribute on object node. So if you're like inside of a resolver and you get that fourth parameter, you might be able to get the schema coordinate as a string and log it inside of your resolver or something. So exposing that is something that I haven't done as part of my PR. That's not described by the spec. I feel like that can be like a follow-up thing. I'll try and get around to that anyway as my next priority, but just kind of calling that out that that's not part of my implementation change.
Mm-hmm. So in GraphQL.js, it's also now its own parser, because before it was inlined in the GraphQL parser, right? As I remember.
Yes. So there is now a separate. Oh, you know what? It's the same. I beg your pardon. It's the same parser class.
Okay.
But then it uses a separate Lexa class, and so
Okay.
parser has like an option now for what Lexa it uses, because it didn't really make sense to redefine. I think I did play around with that. Like I did try and play around with like, let's just completely devolve responsibility and have like its own separate thing entirely. And then I extracted parser to be its own thing for schema coordinates. And then the more I try to like add back in to do the, walking of tokens and stuff, the more I'm like, oh, wait, this just ends up looking exactly like the main parser. So I don't know how much sense that made to do.
It's too much overlap. That's why, like in Hot Chocolate, we also have it as integrated into the standard GraphQL parser. We also use the same Lexa actually for that, because like the tokens have also so much overlap. Just the parse would fail if a token comes like a spread operator or something like that. And you get the
I don't know that the spec forbids that. It just says it uses its own grammar.
Yeah.
So I feel like that's an acceptable. I mean, in my opinion, again, I'm not the, but I feel like that would be an acceptable implementation choice. Probably more of a stylistic to give it its own Lexa class. It does feel nicer, I guess, but I don't know.
It's just so much overlap, like names, for instance, parsing a name, like identifying a name token, for instance. These kinds
Well,
of
so
things.
I'm reusing quite a lot of those helpers. So the read name function in GraphQL.js that then loops over all of the alphanumeric stars and stuff. That's just straight up reused. I think as was the suggestion from Lee. So it's not really like a meaningful difference, to be honest. It being its own Alexa, I think like looking back at what we have now versus what I had before, it does seem to be more of a, it's hard to call it a stylistic choice because like it does. I think I do agree that as we've ended up here, kind of is nicer and a bit simpler, but I didn't like totally hate the if statement before. It was like fine as a one-off thing, but I think this is probably overall nicer. So I'm on board. I'm on board with this change.
Yeah.
Did we get
Awesome.
any update from the July spec cut? Like it was supposed to be July, right?
Yeah, so the spec cut is done. It's basically so there's nothing new going in the spec, just what we have decided on is being polished. And Benji and Lee were doing a ton of work on that.
So that
There's
confirms
something
that
like
schema coordinates is not part of the spec cut then?
Yes,
sounds like
it's accepted. So spec cut means not that it's necessarily merged, but we decided on what's going in. So you have the accepted label. So this is going in.
Oh, cool. Okay, nice.
So this is like there's a difference that it's merged is just editorial stuff. So you can already see here this is accepted.
Sweet. That makes sense.
So there is an overview also what goes in the spec. Where do we have that? I forgot it. There is somewhere a pull request or an issue where Benji linked all the things that go in the spec. Increment delivery. Yeah, I forgot where he put it, but there is an overview issue, which also is used as for every new spec. You kind of have the overview of what was changed, and this overview PR. There you see all the things that are actually going in. Yeah, but there are a couple of things that are not yet merged, but that will go in. And I think what they said is that at the conference we have kind of like a release candidate, if you will, of the spec.
candidate. Okay, but not
Yeah.
general availability.
Yeah, I mean the features are clear. What they're doing mainly now is polishing, like polishing how things are formulated, making them more clearer, and things like that.
There's also, I think, a 45 days window or something like this for validation by
Yeah, the
foundation
TSC.
members.
Yeah, after it's done, right? There will also be we as TSCs have to read through the things and technically
Also,
approve it.
so that's after polishing. There is one phase of polishing, then we have a
Yeah.
release candidate, and then there is TSC validation. Okay.
Yeah, we have to accept the thing. I mean, in general, we accepted the TSC already accepted at this point the general changes, but there is like a review still on that because like the TSC accepts also on the PRs.
Yep.
So, but yeah, it's a while back that we had a new spec.
Yep. And GraphQL Conf is in 1 month and 1 day.
Yeah, I really wish we could have gotten capabilities in. I think it, but I would have rather like to wait a bit more to get that in. But then on the other hand, Lee and Benji are right. There's always this one feature you want to get in. Also defer. Lee was waiting on defer for a couple of years. And it's not in the spec.
Yeah. And
So
we
it's,
don't have to wait two new years to make a new one. Like we could make a new one in 6 months.
yeah, I would say let's do one spec cut a year. I would like that even more, like a very
Oh,
technical
release
spec cut.
trains. Yes.
Yeah, because
GraphQL release trains.
yeah, it doesn't actually, like, there's so much polish that, like, there are also a lot of editorials that sometimes just go in a year. It doesn't have to be a fancy feature, and we could just say this is a next spec cut, right?
For me,
Doesn't
yep.
really matter. Okay. Are there any other things people want to discuss? We can. There's still time.
Who goes swimming in the Amsterdam canals?
Are they clean? I mean,
Are you
they?
doing it, Jeff?
I mean, I signed up. So I might as
Are
well have
they-
signed in blood. Donated some
it-
money. I mean, in for a penny, in for a pound.
Did you ask Martin if it's acceptable to?
Yeah, that's
he made a face. He made a face.
That's the right thing to do. Like, go there and tell a local that you're about to swim in the canal, and if they look shocked at you or something similar, then you better not do it.
I mean,
I was at a wedding. Somebody from Amsterdam was like, "Are you sure?" I'm like, "Oh no, what have I done?"
If you would do it in Switzerland here, like the stuff is clean, right? You can do
Yeah.
that.
That's 1 second. That's a really big misconception. That's a really, really big misconception.
At least here in Zurich, Pascal, it's clean.
Just around you by around your corner in the Royce, there's a lot of people getting. Actually, there's just a whole class of police candidates had to be hospitalized because just up the stream there is a sewage cleaning facility, and when there's rain they pump it somewhere where it can go.
So no canal is safe.
No canal is safe. Open water
No channel
and
is
canals are not safe.
Yeah, like let's see what happens to Jeff if he makes it out.
I'll jump in first. I don't mind. It's funny because I'm doing this off the red eye, so I'm getting off the red eye flight, and like 3 hours later, I have to swim 2.5 kilometers. I'm like, oh no, I've never swam that far in my life.
I can tell you this: I wouldn't do that in Venice. You can see the poo swimming in the channel. Like, it's
Good to know.
It's
all right. Noted. GraphQL Conf 2027 suggestion. Maybe do a boat race instead.
Boat racing.
That's why I didn't commit to it yet. When Jory asked, I said maybe. I first investigate.
Okay.
Okay.
So, actually, Mark, should we send you a Zoom link? Then we can have a look at your question. Then we don't even have to delay it. And we
Yeah,
can do it. I mean, everyone is invited to join, obviously. Talk about composite schema.
So you want to hop over to a separate Zoom, did you say?
No, let's do
I
it
guess
here.
because
I mean, if you have it
should we
here.
do it? Okay, then we just take over. Composite schema takes over the main wiki. That's the main workgroup. That's how it goes now.
All right, we're rating. We're rating
Yeah.
the stream. I like it.
Yeah.
Okay. I'm not good at computers. This might take me a second to work out how to do.
Really, as a software engineer.
Yeah, and that was, when you have to explain a joke, it's not that funny.
Man, I'm using like the desktop. I mean, I'm using the browser version of. Still should be possible. Share. Okay, the share button. Window. Open system settings. This is a new work laptop. Give me a second. I've got to add Chrome. I am going to quit and reopen. I'll be 1 second.
It's a Mac.
Yes, I'll be 1 second. I'm going to reload Chrome. Hang on.
Yeah, it's a typical Mac. When you have a new Mac, you constantly have to reopen apps.
I'm gonna run too. Have a good one,
Yeah,
guys.
see you. Awesome. It's also when I switch from one Mac to a new one, it's always the first 2 weeks you're constantly reopening apps.
Yeah, I hate setting up a new work laptop. Okay, this is basically the problem that I have. I have it like distilled in another Google Doc, which I'm not sure I can sort of publicly screen share right now. But here's here's the extract from it. So I think actually these are the same problem, but have two different solutions. This is, I think, the minimal representation of the problem. And
Can you keep it on?
yeah, sorry. I'm just reminding myself. So
Yeah. So Chrome.
yeah.
Okay.
I see. I see.
But this is a general GraphQL issue, right?
Well, it's the cascading thing that is the problem. You would have to defer foo so that you get the response from foo quick so that you can actually call. That's a very interesting case you've got there. Because
Yeah.
because essentially what you would want to do in this case is probably propagate defer down to the downstream service and say that actually I want to defer slow field 1. And then this should slice the request so that you actually issue 3 backend requests instead of 2. So the first request should fetch the slow field in parallel to the foo1 foo ID field.
Yeah.
And once this is resolved, you can dispatch the second call.
I think that's probably exactly how I'm just gonna screen share the relevant bit from here. I'm gonna switch tabs a little bit. Share to this tab. Yeah, this is probably okay to share. Okay.
But this is in general a defer and stream problem, right? It's not necessarily
The client. Yeah, I previously in a separate GitHub issue said this kind of wants to be like an internal defer. So in the link in Discord, I link to a GitHub issue, and then in that GitHub issue, I link to a gist, and there's a whole like history around this. I've been trying to I've been trying to talk about this for a while, but this is the solution that I've come up with internally, which is to kind of like hack the query planner by breaking apart the schema and sharding the schema for this foo schema, so that we essentially fetch both in parallel, as you were saying. So we want to fetch slow field 1 in parallel with just the top level resolver for foo, and then then you can fetch the slow things in parallel. I don't know if that's making any sense or not.
Yeah.
Yeah, it does. It does make a lot of sense.
It's
we do. It's not part of the specification, but what we are thinking about is including cost in parts of the planning.
We do already, Pascal. Like
But we wouldn't like this would in our cost analysis, we don't have an exit for this is too expensive. We have to split it into query.
No, we
It would
would
still be one query, right? But technically, this could be part of the cost that you essentially have an algorithm which decides that, hey, I've discovered that when I include this field, it's much more expensive to fetch, and then you actually issue two queries in parallel to fetch the data, right?
Yeah, but I think fundamentally it's not a federation problem, right? This fundamentally is a GraphQL problem. So the client actually should specify the differs in the original query for the slow fields, and then these parts are deferred.
Yeah, I mean,
I think I disagree with that statement because ultimately, number one, the client doesn't want to get a deferred response. It still just wants to get a single response. Any deferring that happens should be like an internal buffering, and like the router might want to defer internally, but kind of buffer that deferredness down to the client. And secondly, I also don't think it should be a property of the I don't think it should be the responsibility of the clients to know, hey, I want to have this be like an internal defer thing, because then you're asking basically client developers to start doing like performance stuff, and presumably it's always going to be like a consistent property of this resolver is going to be slow.
No, I get the issue because in this case you have the technical implementation detail that the router in this case does two requests, right?
Yeah,
of a standard GraphQL server. This would be resolvers that already run in parallel, so you don't have the cascading effect of these 2 seconds one after the other, but you could have them parallel in a standard GraphQL server.
It makes it much slower, right? Like technically it could be resolved in roughly 2 seconds, but it takes 4 just because of federation. Like if you would have it on a single GraphQL server, you have 2 seconds to more or less 2 seconds to resolve the whole request. But by introducing federation, it now takes 4. And
that's precisely the issue that we ran into at our company. And as far as I can tell, this is an edge case, but also like a legit problem.
Yeah, but it's not. Yeah, it's not a specification, or where I'm coming from. It's not a specification error. It's a query planning strategy.
Yes, I agree. This should we should be able to signal to the query planner, hey, actually, it's safe to send these 2 requests in parallel rather than having to, do them one after the other in a waterfall. The way that I'm hacking the query planner, which is this will be what I essentially do my talk on at the conference. Knows how you can do this today is by lying, by
you lie to the planner.
Yeah, well, like just like you can see in the diagram here, like we take this original source schema and then split it apart, and you have like just the slow field be in a separate schema, so that when you compose the schema, that one schema is actually now 2 schemas with 2 different like subgraph names, and so the query planner sees them as 2 different subgraphs and thinks, oh, like it's safe to I'm just going to send these in parallel, right? Because I have to send them in parallel. So that act of the planner sending these like subqueries in parallel, I feel like could be done if the query planner was able to do that natively, which is kind of what I'm hoping we could get out of the composite schema spec.
Yeah,
without having to do this.
I think
in the composite schema, we decided to leave these implementation details, like of the query planning, up to the implementers. Like we don't specify the query planning algorithm, and we do that
we have one which is on purpose super inefficient, so that you don't come up with the idea that you use it. Essentially, have as soon as you start Cartesian explosion, and it gets very, very complicated. So
yeah,
I think, yeah, I see what you're saying now with like, we don't want to specify the actual algorithm. I think that makes sense. But perhaps exposing some kind of like built-in primitive or directive, which then can be an input into whatever your choice of algorithm is to,
But
facilitate
how would
this
you
parallel.
split it? I can see you can say split it, but actually you only want to split it if there is like two of these fields. Yeah, no, you could always split the expensive fields. I mean, you could
Yeah.
also drive that on open telemetry data, right?
Yeah.
Like
And
if
to
you
be clear, like, I'm not suggesting that that my directive here is the correct implementation for the composite schema spec. This is just like a thing that I know works for for us internally, and it's a thing that we can monkey patch.
Yeah. So we have
follow with.
I think for the core specification, we try to shed out a lot of stuff which we have as ideas, which we're not sure how to if it's worth putting it in the core specification. So there could be an appendix for it where the directive is described, and then the compatibility page of composite schema, we can say that this service supports this implementation supports this specific version of the composite schema specification, but also these extensions, right?
Yeah. Yes. So the I don't know if you read into what's there already, but the composite schema specification also specifies uh, um, not everything that is out in the market. Like we looked at all the solutions that are there. Like we looked at Fusion, at Stitching, at Apollo Federation, and took like the core sets of ideas from them. So you have the lookup concept. Are you familiar with the?
Yeah, I am familiar with lookup, and so in the Discord, I posted 2 problems. I think both problems are the same, have the same like root cause, is that we don't have a signal to the query planner to break both things. Well, I think the first one is solved by lookup. I think so. I think I'm relatively happy with that as a solution. The
What is the
second,
problem that you think there?
I posted the GitHub link there. Let me sort of share my screen, or maybe you can bring it up if you're ready.
Is it in the Discord channel?
I don't know.
I posted it in the, yeah, it's in the Discord channel. It's also in the meeting chat window here. Yeah.
Okay, let me check quickly.
Leaking the TSC channel.
Sorry. But there's nothing secret. That's it.
Nah, I'm joking. So that first item, yeah.
Let's have a look. Okay, subgraphs are blocked from resolving contributed entity fields. It's in this case, we have this guy and subgraph A. It's ID and name. Oh, because you mean it's cascading here?
Yeah, it's the same flavor of problem, but I think because it's nested on a type, we can use lookup here.
Yeah, and did you, so with lookup, we have this internal to give you control over this. So the idea, like we have inaccessible and internal is like there are lookups that can just contribute data to an object, and there are lookups that actually can say I can get this identity, right? If you ask me for product 1 and I return you data, product 1 exists. But there are also lookups where you pass in ID 1 and it maybe always produces an object, just completes fields on that, right? And these are internal lookups. So these must run cascading. So you first have to enter through a non-internal lookup, and then you can serve data from can complement that. But if both
Okay.
lookups are entry points or meant as entry points, then you can use them
Also,
I think
without.
quick correction here. Also, internally, with internal lookups, if you have this type nested, so not on the query root, it would also be able to be executed in parallel, of course. Like if you have let's say you have whatever field and that returns a user, then you can you can execute the internal lookups also in parallel, right? Because they're just server internal to contribute data.
Right.
Stephen
I
has
wasn't-
joined.
Hi, Stephen. I wasn't able to fully confirm about lookup because there's nothing in the spec that describes the behavior of how that would solve this problem. I think it's sort of like hinted at, maybe. But I couldn't confirm.
This is again a query planning strategy. You could always
Yeah.
say, I wanna. You could always say, I'm doing it sequentially, right? It's not
Right.
wrong to implement it like that. But you could also, in this case, say I have two public lookups here, so I can use them because data is semantically equivalent, so I can just issue them both.
Yeah, the main just so you know, Stephen, the main work group is already over. We just took it over for a bit more composite schema because we haven't talked about it enough today. So just so you're aware what's going on here. It's the Wild
I
West.
was suspecting as much that.
So the main difference between the internal and the public lookup is just that what we want to avoid is that you have to synchronize your identities across all different services, right? So when you have a product by ID and you just want to contribute a profile photo, but you don't really know all users because there's users which do not have a profile photo, then you cannot have a query that calls the profile fetch just the profile photo, because you would have to first identify if you actually need to return an object or if it's null. So that's a bit the reason why there's the internal and the public ones.
There's also a bit. So go on.
No, go ahead.
I was gonna say, like, so there's two other things that occur to me. Number one, this solution does carry this like slight downside. So someone commented in that thread that you have to like you're going to be calling the same resolver twice, and you want to make sure that it behaves identically, which I think is already the case for shareable. So like I'm not concerned about that, but this being a primitive that allows this optimization strategy is like slightly risky, and like theoretically you might have some like guarantee that you need the result to be like idempotent, but that might not be the case. So there's like potentially some kind of like edge case here. I don't know if that's the responsibility of the spec to.
I mean, that's a federation problem anyway. When a query executes, it could be that like in the absolute worst case, we rely on okay, so if a query executes on a GraphQL server, you can use data loaders to guarantee that the ID of an object is always the same. But when you use a federated graph, even if you have cascading calls, it could be that when you enter the query and you do your first request to service A, and then later the cascading request to service A is a second later, it could be that the data has already changed on the service and this identity does no longer exist, even though that you have fetched it before. That's just a distributed.
It's just a non-obvious thing that in the case of this being like a transparent performance optimization, by like the unoptimized case is that your resolver gets executed once. But in the optimized case, the resolver gets executed twice because you're hitting it in parallel. And if there's any sort of randomness, that could like potentially be an issue. And it's like why you might want to do like the, execute the resolver twice, like how React will render things twice to make sure that you're not accidentally Yeah, go on.
So that's the case with lookups. That's the difference between a lookup and just a public field on the query type. The semantic, as soon as you say semantic of lookups, you have essentially a pure function. You pass in ID1, you get back the object with ID1. There's no randomness.
So you
That's
should have the assumption that if you're applying lookup to a field, that's you basically the developer giving a guarantee that like this resolver is a pure function. So I think that's probably like a yeah, I think that makes sense. And I don't know if that's called out in the spec, but I feel like that's a reasonable kind of agreement to have. So I'm satisfied with that.
Yeah.
Is lookup so go on.
Yeah. Also, like if you, for instance, have this internal lookup here, right? That means in the merged schema, this is not an entry point. Like in this case, we would, but this is also query planning optimization that you could do, right? You could still execute them in parallel, but technically, this can verify that the object really exists, like is the entry point. And this just can, an internal lookup can just contribute data to an object that you have already. Right? If you take this away, then they are both entry points and you could parallelize them. Makes that sense? Does it make sense?
I think so, yeah.
Yeah, and if you have like a lot of these, like also if you have a lot of internals in your query plan, then you can also parallelize them however you feel fit.
Yeah. I'm still not sure how this applies to that second case that I posted in the discourse.
Yeah, in yours
I'm
it
not-
was an entry point, right? An entry point that we have there, like this guy. So in your case, you
so
have
this is the option. This is like the first problem. So I posted two problems. This GitHub is the first problem, which I think is solved by lookup. That's what you just said. But the second one, I think I don't. It's unclear where you'd apply lookup to solve that one. So I'd be curious your thoughts on that.
Yeah, but in this case, if you would have a query type here with user, right? You have an explicit entry point here, and then we could parallelize it. You could also say I don't.
Yeah.
So this problem would be solved by lookup.
Yeah, this one I think I'm convinced makes sense. I think I understand how lookup
And
solves. But
the
the other
second
one,
one, you mean this guy here?
yes.
Yeah, and this I think is query planning strategies. Like you could use cost for that and say, if like we have in the query planner, for instance, cost, we could optimize it a bit to say if the cost of a field has this threshold, then it needs to be split off in a. These are the slow parts of this thing. But this is a query planning strategy, I think. It's
I
not.
agree. This is just a query planning strategy, but I don't know what
Yeah.
the mechanism to like signal to the query planner, hey, I want you to execute these fields in parallel would be.
It could just be that this is a very costly field, and I think there's two core things. So first off, you could just annotate it with a high cost and then specify what your burstable cost is, right? As soon as you reach this cost, you try to slice the request. Or you annotate the field with that you actually want this field to always run in parallel. But this is not something which is baked into the specification per se in composite schema. This would be very implementation specific, how this would be implemented in the.
How do you guys do that, Stephen? Or do you know this problem here?
I haven't been following. So the problem
Okay.
is
The problem is like you have this query here, right? Where you have a slow field, which is 2 seconds expensive, and the other slow field, 2 seconds expensive. It's distributed into this design where you have on one subgraph, basically here the query type with the slow field on, and on the other you have the complementary part where you get the slow field, then which is on the query name, which completes to the foo field. And what happens is now the router will go and issue the first request, get this request, which takes 2 seconds, and then grab the requirements to call the second field, which is then 2 seconds, which kind of adds these 2 seconds together instead of slicing foo off of the first request, kind of creating 3 requests.
Ooh. Let's see.
So
If
that you
you
get
let me share the screen, I can show you like the after of what
Is
we
there a
actually want.
dependency between those? They should be in parallel, right?
Well,
There
yeah,
is
but
the identity is fetched with the first request, right? You see the
yeah, I
ID,
mean,
the ID is fetched with the first request, and it needs the ID to fetch the slow field later.
yeah,
Yes,
in a
for the
greedy,
audience that I wrote this for, I didn't include the like, the entities that like the actual subgraph request that the router will send. So it's sort of like a pseudo request. But yes, it would include the ID, which would be the dependency, and as to why like the router has no reason to break the query apart in this way, because it just sees foo and slow field 1 as being on the same graph. So it thinks, great, I'll just be efficient, right? And make one request to the subgraph and wait for both of those things to complete. But that's not actually what we want to happen. Like the more efficient thing would be you call slow field 1 and foo in parallel. And so the question is, how do we signal to the query planner to do that? And like my little split schema thing here is the way of doing that in the status quo with federation. And I guess we're talking about like how we would signal to the query planner that it's okay to break that apart with composite schemas.
yeah, it's typically you are greedy, right? You want to have all the fields for one subgraph, if possible, in one request. But in this
Yeah.
case, you can't. I mean, it could be telemetry driven, right? You might have an initial. Yeah, but that's not good, because you would have an initial query plan that's slow and then optimize it. Which
I would also say that anytime the execution of anything changes, like any significant changes like this, I think we want to be
declarative,
not
yeah.
like exactly. Like when we're rolling this out internally, people want to do it in like a 1%, 10%, 100% kind of thing, rather than just it sometimes does it, sometimes doesn't, magically does it, sometimes does, because it does change the behavior. There are cases where like a different code path is taken. Like it is theoretically possible that some global variable thing that's set in one resolver that's consumed it's theoretically possible that it's not actually safe to break it apart in this way. And if the system just like magically does it without a human knowing, then that's bad. So I think having it be declarative as to like, yes, I know I want to execute this field in parallel against all others as its own thing. Having it be a declarative thing feels like a good idea.
But to be honest, like if you have 2 slow fields, you would group the 2 slow fields into one request, or?
Why wouldn't you just have them be independent and have the network parallelize?
Yeah, because it could be cascading at some point, right? If you use many split fields, split schema requests or split field requests, and you have many slow fields, it would be much more efficient for them to be issued to the same subgraph in one
I think it's fetching the identities, like having a threshold and fetching the identities in one request is key, right? So you actually fetch the tree of identities, and then
that's actually what you want to do.
That's I think what's happening here. So when we break apart the schema, we're calling just the foo field first, and all it's responsible for returning is the ID. The slow field 2 comes from like the bar, comes from like slow field 2 is slow, and that's coming from the bar subgraph. So that initial foo query happens, almost instantaneously, and then like, okay, it takes a bit longer than 2 seconds because you've got to wait for that foo field to complete, but we assume that's quick. This is the thing that's expensive. So, but like this is as efficient as you could write if you were doing it by hand without federation all in a single service, right? This is like theoretically the most efficient that you could do it. So I think that's good enough. But you still have to like pass this list of IDs to the bar subgraph, which is not a dependency expressed in this little diagram, sadly for us. But yeah, it's there.
It's actually
In practice, what we do with this is, well, the query plan stays as is because it's simple and easy to to intuit what the query plan is going to do. But then we look at the services involved and say, okay, if this is too slow, can this be made faster, or should we change like which DGS's own, which subgraphs own these fields? Like, have we gotten something wrong in how we've broken up things between services? If we have weird,
you do the split schema manually with.
Okay, it goes now in its own
you
service.
Yeah,
The
move
manual
the
thing is just send two different queries from the client. So like the first, like the simplest option is actually have the client send two different queries, right?
Yeah.
You would send a query for slow field 1 just by itself, and then you would send a query for that foo and slow field 2 thing.
Yeah, that's
actually if you think about it, what you do here is so if you formalize that, is you would in the first request in the what you have now foo base, right? You integrate still greedy all what is requirements, and then all the other fields you could group in the slow request. They are not needed for consecutive requests, so you still get the efficient. I get all the requirements in one request, and there could be many requirements if you have a deeper graph, right? And the slow, it becomes problematic if a slow field is also a requirement. Like, and I don't mean just the requirement as the requires directive, but a requirement to get more data.
I'm not sure I follow. I feel like this set of subgraph calls is the minimum set of subgraph calls that we could make. I mean, efficiently. Are you saying that this should be reduced somehow?
So I'm just arguing if there are more, if you have in a schema suddenly a lot of slow fields that
So if you had like
that you
slow field,
annotated.
yeah, if you had slow field 3 as a as a sibling of slow field 1 in that root selection set, then I guess, and it was also in that foo schema, then I guess those could be batched together. There's not kind of much value in, I mean, there's not much gained or lost by having it grouped together.
It could also be, and that's something like Apollo I think doesn't do at the moment. They do I think they do the defer in the router, right? And what Steven said is you could also use defer. And if you rely on your subgraphs can all do defer, you actually could do a defer on the slow fields and still send it as a single request.
I mean, just to chime in here on defer, like if you build the UI with relay, that's exactly the thing that you would want to do. Like you would, the idea of sending two queries, when you tell a relay developer to send two queries, then they turn around and walk away, because they actually only really want to do one query always, and that's where defer is super handy to do, because you can just defer the slow parts. But then you also have to propagate it down, right? You actually have to slice the requests correctly.
Yeah, but I go further, Pascal. Here, it's not that the user have to specify defer, but if the backend engineer says this is a slow field, marks it as a slow field, the gateway would start putting defers around these things.
Or the gateway automatically defers everything that's not a dependency for the subsequent requests. So
that was what I meant before. Yeah.
Oh, that's actually a super crazy idea. I like it.
Yeah, all the requirements.
I like it.
you defer everything what is not a requirement, like what is not needed to issue new request. they would be always the fastest.
That's super nice.
But see, it's not a specification issue. It could also be just the query planning strategy.
It could. I mean, that wouldn't even be query planning. That would be execution. It would be part, but the execution
it's query
is very
planning.
different. Yeah, but the execution is also very
yeah.
different, right?
Yeah, because you need in the query planning, you need to figure out what is actually a requirement for another sub fetch, and everything else is deferred.
Mm.
Yeah, you could. That is a genius idea, Stephen.
See,
Now,
so I've been
the
thinking
thing
about the defer between like gateway and subgraph, and what we could do with that once we support it in the subgraphs, and this was one of the areas that could really help.
Yeah.
I think the idea of like internally deferring, we spoke about that, I think, Stephen, before you were on the call. In my original gist from like a few years ago when I was still trying to think through this, I think there's like a GitHub issue for this somewhere with the idea of like internal defer. Yeah, here it is.
And if you structure the request right, the defer is actually top level. You generate everything that you need for now, and everything else you split basically the subgraph query. Everything in the defer what you need not to have now, and everything that you need for subsequent request is in the non-defer.
I mean,
that would be super fast because you get that immediately.
Steven,
the requirements immediately.
Why did you have to say this now? Conference is in a month, and now Michael has new ideas. Like we were so
yeah, but it's
close
so
to
simple.
Yeah, it's like,
get
okay,
it
we need this
working.
implemented in 28 days.
Yeah,
Go.
well, the problem is that they will.
Would this be like a property of the schema or the query?
No,
Well-
it's like so this requires so what we anyway do, like I don't know if you know, we have this variable batching and stuff like that, but not all subgraphs have variable batching yet. So what we do in the implementation, in our implementation, is we have capabilities per source schema basically.
Okay.
And if the source schema has a capability for defer, what you could do is, can I share the screen?
Yeah.
Quickly, let's see if we have concrete example. Snapshots. Okay, that is not so good. The thing is, with test cases, you never include the unnecessary data. Do we have one? Yeah, let's take this one. Okay, let's say we have a query plan. Like you have this request here. And for, let's see, we need ID, we need dimension and dimension height, right? And that is needed from this initial request. And what we could do in this case is this data is actually needed. It looks a bit stupid at this point, but we could have here a defer. Typically, you have more data there, right? And then we take all the parts that are non-essential and deferred in the second. So now we have the requirements that we want immediately. And I mean, here's field merging, right? So this is not two calls. But this field would now be deferred. And if you have subfields that you have in here, like, I don't know, reviews, where you get the body, this would all be in the deferred direction. And that should be faster and less, because you get the response immediately from this part. And then all the non-requirements, like where the consecutive steps not require this, are deferred.
So if we were to take it back to the slow field foo slow field 2 example,
yeah,
I'm imagining we'd wrap defer on slow field 1, but you're saying flip it and add defer on foo, which I think would be the.
So your example was like this, right? We have foo.
There we go. I just sent it in the sidebar.
Let me check that. Yeah. Yeah. So this guy would be rewritten into wait,
That is the same way around today.
Wait. No.
Yeah, I think that looks similar to the
Why?
SIM2 proposal.
Wait. Where's my language switcher? There.
Yeah, it was there. Left of finish setup. There, the C#. Left of it.
This.
No, between, no, right? Yep, this one.
Because okay, thanks, Pascal. Sometimes.
Okay. I
Why did it even think it's C#? Yeah.
But that's wrong. That's wrong. So slow field 1, so what you have to do is
yeah. Oh, sorry. This would, in this case, would take this, right? This
yes,
would
exactly.
go in here. And the second thing is still a request, because it's in our case, it would be, if we have a lookup foo ID 1, and then we would get slow field 2, right? But the idea is, like, this is a very simplified example, right? What I want to show with an actual query plan, if you have lots of data in that graph, we would just slice a subgraph request into what is requirements, what is needed for the consecutive step that would be sitting outside the defer, and everything else would be sitting inside the defer. Like if you have also, let's say you have here also a name in there. Even though this might be fast, we would not even bother in measuring if it's fast. We would just put it in the defer.
Yeah, and so this is, it looks like in that gist you shared, Mark, like this is your number 2 option.
Yeah.
But you mentioned there that we don't want to stream the response to the client. And what I was thinking is that we wouldn't, unless the client specified something deferred, it would all be, isolated to the gateway.
Yeah,
but that does
that's
bring up probably the most notable downside here is just the complexity in the execution. Your execution now becomes very, asynchronous, collecting, make sure you have all the requirements, then you can fire off your next request.
Yes,
I think that was the motivation. I think that was the motivation behind calling it internal defer, was to signal that it was like deferring internally, and then it's like a transparent thing to the client.
The use case, it's suddenly not anymore the client that uses defer, but the gateway using defer to make this request faster, and that's why
you still have the issue that when you have 2 slow fields, that the 2 slow fields have to wait on each other.
No, now you don't have. Depends on if the slow field is in fact the requirement, then you will have to wait.
Yeah, but there's nothing you do about that besides. There's nothing you can do about that in your gateway.
No, but
you have to go back to your service owners and say fix it.
Yeah.
Could you update the name on line 14? Because I'm having trouble interpreting that. That's not inside the selection set to foo.
This where 14?
On line 14.
Yeah. Sorry. Yeah, this is wrong. but you get the gist. This should be like this, right?
No,
Everything,
no, it's wrong. It is, yeah, sorry, it's right. Sorry, didn't say anything.
everything that is non-deferred with AI, it's the order, right?
So then
be
the
like
difference here, and maybe this goes back to what I was saying earlier, if you look at this now, that foo resolver would be executed twice, right?
No,
Are you sure?
that is like the defer specification has a normal deduplication algorithm. That's why we held up defer so that we have not two executions. So it would this is field merged, and defer the server executing defer would really only defer the parts that, like, it would go through here, would find slow fields. Okay, slow fields is executed in parallel. Then it would
Okay.
execute here because this is field merging algorithm, right? And then it
Got
would
it.
get the ID, and then it would defer name.
Got it. Okay, that solves, that sidesteps the issue that I was gonna
Yeah.
talk about there, which is this being a transparent perf optimization might actually cause a difference in execution behavior, such as like globals or whatever, and cause a like, unexpected undefined behavior. But if that's not the case, then that's not the case.
Yeah.
So that's good.
It's by the way, the defer that most people at the moment use, which is an early draft, would duplicate here. But the algorithm that Benji and Yakov worked on, that is going to be specified, is deduplicating. So you wouldn't have two foos.
Great.
Because
And so this
technically
like
there is-
query, sorry, go on.
Technically, there's no released version of defer, right? So
Yeah,
that's
there is no
why
defer.
we can talk about defer doesn't do this, even though that most of the implementation at the moment that support defer will actually
Would
do
do
it,
that, yeah.
would do the duplicated execution. But
Yeah, but
the
what
intention
I'm saying is
not do it.
yeah, but what I'm saying is the specified part. So the current proposal, that is not that is deduplicating, and that would actually solve this problem here, because then you could just slice always, and you don't. And I think that is even better because you don't have to think about this is slow or not slow, and maybe whatever. It would always just get the requirements first, then issue all the rest.
So I think this is sort of like definitely an option B, rather than having the query planner just send the two requests in parallel. But has equal merit. I think it makes sense. My question is still how do we signal to the query planner? How do we signal that we want this like defer behavior?
Well, what's brewing?
Yeah,
what's
you wouldn't. You wouldn't.
Michael's- what's brewing in Michael's head at the moment is to do this by default.
Right.
Yes, I would do that by default. I would always do that because then it's. I mean, defer is specified that if like the server can override the defer also. Like the subgraph could say this name field here is anyway a scalar, so I'm sending it with the initial value, right? Like in the defer specification, we also have the opt-out from the downstream server. You can say, I want to defer everything, and the server says, that makes no sense. So I'm taking out the defer for this part.
Yeah, so it gives the power to the subgraph server to decide.
Yeah, I'm just saying this is for me important. I want this first. And then the subgraph suddenly can decide, okay, this doesn't make really a sense because if I have the ID, I also have the name, so I'm sending it in the first request.
Can the server deliver all of these contents as patches based? Like, is there any rule where you put defer to slice the patch size? I'm not up to date with the current specification. So can slow field can foo name be returned before slow field 1 is returned, or does it have to be the whole selection set in one?
Yes, no, can be before.
Or it can
like
be
the new defer specification has a finer grained slicing.
So the server can slice whatever it wants to slice in defer.
And that's important, otherwise you cannot deduplicate.
That's really cool because when you think about it, this is actually a fantastic execution algorithm because you most likely this is exactly what you want.
I mean, it requires you to have the defer implemented on the source schema, right?
Yeah,
But
but think about it. It's 90, like it's essentially what you do is you execute the important parts of the query plan as quickly as possible so that all of the services know as soon as possible what they have to deliver. And then you start patching in the data which the client then lazily
yeah, the one thing like in our implementation, we still in our implementation, it's like this, that we execute a request and we basically wait for the request to finish, right? Before the next before the next nodes can be executed. And you have to change this kind of as soon as you have the requirements, the next part can go on. So the query planner has to, or the execution of the query planner has to change a bit.
But I guess defer, it should require that the first patch, the first bit of data you get back should contain the requirements, right?
Yes.
So I guess
That's
then
this
it's
part.
fairly simple. You just say, okay, once I have the first bit, then I can proceed and let everything, just test complete before we return to the client.
You can even start bubbling. Like if you know that, I mean, that's now crazy, but if you do a request, you have a nullability issue, it bubbles up. You can actually say, okay, I don't need to wait for anything. Like for the slow fields, I can just say that I cancel the request because it's going to be null anyway.
There's no null anymore.
Yeah,
we changed GraphQL.
yeah, I know. I'm also not up to date on this front. It's
I liked like Stephen, I saw you talk. Actually, Benji sent it over to me.
Nice.
just for a couple of weeks ago, and I was like, it's such a good explanation. Like even my kids had to laugh about the sandwich.
I'm honored that your kids watch my talk.
Yeah, just the bit where you said, "Oh, sandwich is gone." Now, where do I get the peanut butter? It's
They're like, Dad, I am now even more confused about what you do for a living.
Well, Mark, this is actually very insightful because that could actually change how we do the execution. Did you play around with this idea, Stephen? And what you never did?
Defer, no, because our subgraphs don't handle defer yet. So
Right.
But you're using GraphQL Java as a subgraph, or is it Spring Boot, or is it still DJS?
it's DGS, yeah. So DGS on Spring and GraphQL Java. But yeah, and then also we would need to make that the kind of the contract with a gateway, and
Yeah,
we would require some re-architecting of our gateway implementation as well. So it hasn't been enough of a problem that it's warranted that.
I think that's the thing I've
it's
run into, is that no one seemed to care about this until this very meeting. So I think it's been an edge case for us. It's been an edge case for everyone, it seems. But
But
I am.
yeah, but it could
the edge case leads to a potentially better execution algorithm for everything. Like
yeah,
Right.
because it could like if you get the requirements early, you can start the other requests more early, so it could get a
Yeah,
better overall performance.
This makes total sense. I'm still. I just want to ask one more probing question, which is if you can copy and paste in
Oh yeah,
that query that I have, or rather, if you add in on the selection sets to what have I got there? Some kind of weird error. But basically, I'm just thinking if there's another nested slow field. So I guess as a sibling of slow field 2, you have bar, and then in a
yeah.
selection set, no, just as a sibling of slow field 2, just like a new field. So bar, and then in the selection set for that slow field 3.
So this would also which subgraph do we put it
So
on?
this,
1 or
so
2?
that, like this is like the bar subgraph. So now like the bar subgraph is like, this is like the most contrived example, but so now like the bar subgraph is executing that slow field 3 thing.
It's
So it'd be,
it's a third one.
so it'd be a third subgraph. But if it's going inside that same defer to, if it's going inside that same defer, I don't know if that's gonna. Sorry,
This
I'll let
makes
you.
so it's going into this subgraph.
It needs the ID from foo in
It
order
needs this ID.
to. It's going to need an ID from foo. It's going to need an ID from bar. So it's kind of, it's still going to be like a waterfall, I think.
Okay, so it's this. So this is subgraph. Let's call them 1. This is 2. And then we have a third one, you say. And this third
Yeah.
one has it has also a dependency on foo here, or does it have on bar?
Transitively, it's got a dependency on foo. Really, it needs the ID of bar.
So it would be like this.
Well, I suppose if you're doing it as like, dot 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 on entities thing, it would be on the bar entity with an ID of bar, right?
Look up bar by ID instead of
Yeah.
foo.
Okay, so we
Yeah.
would end up here fetching bar. So in this case, we would fetch here bar, get the ID. Is it like
Yeah,
this?
like this is why I'm wondering if there needs to be like 2 sets of defers or something for this use
No.
case.
Yeah, because like it's field merging like this. Like if you would do this, let's take the defer just away to get this. Like if you have these, right? In the GraphQL field merging algorithm, these are merged.
Yeah.
It's not that we execute 2 times foo.
No, Michael, what he means is that you actually can issue the get slow fields query to as soon as you have ID. You don't need to wait for the resolver bar ID to resolve. So that's why he was talking about 2 sets of defer, right?
Yeah.
Why 2 sets of defer?
Because you can, like, now you have to wait until foo is resolved and bar is resolved. But technically you could.
But yeah, I mean, you can
I
drive
guess
it
you
over the
Well, so
top,
what if you
but
defer everything?
yeah, I don't think that
Yes.
it's getting more efficient because you're branching. Like I would say, you are branching now so much data.
So if you defer everything, then you just have to wait and say, okay, as soon as I got ID, I can use that. As soon as I have bar ID, I can use that.
And when you say
And then
defer
it's also
everything,
not. Then it's also becomes from the query planner much more complex, right? Like in
so you mean
complex.
you mean like the selection set to defer just has like the minimal, like you defer slow field 1 as a separate defer foo as a separate defer. So like you'd have like the minimal number of things possible in the selection set, so as many defers as possible.
Yeah, but it's not getting faster. I can guarantee it.
We're just yeah, like so even like bar ID is deferred and foo ID is deferred. I mean, can you
Yep.
Okay, for
What's it?
defer, if we put everything in one big defer group, can the subgraph still return us the deferred items in batches as they come? I'm not too clear on the details of defer, or does it have to be?
You mean if we
all in one set?
So if we put everything in defer, like
Yep.
in one big defer,
Yep.
I don't think they're having a new patching, but I don't think that would automatically do that.
Is it not? Okay. Because yeah, I was thinking the subgraph then can return just the data as it comes, basically.
But it becomes complex, right? In the query plan, think about more complex requirements and stuff like that, because now you have to wait until with this you can very very easily plan dependencies between these requests. So when this request is done has the requirements, you know that all the other dependencies on this can start. But now you have to pinpoint, and sometimes requirements are distributed across, like you have to actually grab requirements from several subgraphs and merge them. And now it's not just guaranteed when this is there that parts of the requirements is there, but you have to really inspect the data.
I think the query plan could be the same, but in order to execute optimally, like you could always do it naively and wait till you get everything to execute subsequent requests. Or you can on every patch check to see if we can execute now.
Yeah. You would really need to inspect, okay, do I have the data for this?
Exactly.
With this, it's very easy, right? The soon you have this, go. And then you can patch in the rest. But if we start deferring on this.
It's,
I will say it does make
kind of a harebrained idea that's probably more complex than it's worth. But
it does make the query plan harder to reason about, because I like that with a query plan you can see this is like the static declaration of requests that will get sent. That's easy for like, an operations team to reason about, whatever. Versus now if you're saying that this is a static query plan, but actually it's not static, this request might be many requests. I don't know, just a thought. But I definitely see value in this. Certainly the service capabilities thing, meaning it's more a flexible thing. I'm still like in the back of my head thinking there is potentially some contrived like depth of 3 counterexample here, but I think I need to spend some more time thinking about it. But at least that would be like an edge case of an edge case. But something like this definitely seems hugely exciting.
Yeah, I think to optimize this now, you have to have an example that shows it's really worth.
Yeah, I don't have that example yet, so I'm not gonna take up more of your time theory crafting that.
I mean, that's the example for this. To defer this is super easy, right? Bar is just rename bar to slow bar. Then you have the example. It's very easy to craft. The question is, how do you know?
Yeah, but we are like typically the getting identities and stuff like that is cheap.
Yeah, I think
it's most of the time I would argue that this kind of data, gathering up the IDs, is not the expensive part.
It's the things where it's like there are real world sources of slowness where it's like get ads or something like that, and you got to wait for like the ads thing to happen.
Exactly. Or get here, and I don't know, something from a blob storage somewhere. Things like that. Where
LLM response. There are like definite things where like the ID, it like just getting the ID is slow. And so then you can imagine that cascading down to like various sources of stages of legitimate slowness. And if you're doing like the relay style one big ass query, but these like slow fields don't actually have dependencies on each other, then like that's where we get into this situation with very real world good reasons that no good solution today to solve. So whilst I agree it's going to be complex and apparently an edge case still, I might want to think about it on it some more just to kind of show what. I think like renaming bar to slow bar does give that example, right?
Yes, my argument is you have to have a real world use case for this, because often these identities come from database systems, and typically that's not the slowest part of the.
But also sometimes not. Also sometimes
I know.
Yeah.
But to make the complexity, I think.
Yeah, I agree. So I like I said, I don't want to take up any more of your valuable time, but thank you so much for this discussion. Yeah, if you can invite me to the Slack, then that'd be great, and maybe we can keep chatting a bit more. I think
with your email address, or do you do Slack connects?
I'm sure I could get Slack Connect. I'm probably gonna ask my IT admins. You can also just add me directly. I'll type in both my emails here, like my work one for Slack Connect and mark@lara.me. Yeah, mark@yelp and mark@lara.me. Let me remove that one.
Okay.
And then I think specifically what I might want to chat about is, like I said, I'm still waiting for confirmation because it's been a while since they emailed me, but I'm supposed to be giving a talk at the conference about this topic. And so I'm specifically going to talk about like the split schema that we have for solving this today, like hacking query planner. But then I'd also like to, you know, not set like that, not give people bad ideas and be like, maybe you shouldn't do this. Like you should just wait for the composite schema spec. Like here's how we're thinking about it for realsies. So I want to make sure I'm not stepping on any toes and giving sort of accurate information there.
No. I mean, this is if out of
Until the
box,
conference, I have implemented that in our query planner, and then I can say it's not true. Look at this, how it works.
If you get the talk like right after mine, ignore that guy.
Yeah, but
Okay.
but I think this, like, I would say this solves 90% of the issue.
Yeah. And then, as you say, it can just be left to sort of like a implementation detail rather than having to be a spec defined thing.
Yeah, it
although-
reduces the request pressure on your subgraph, right? It's a single HTTP request that takes 2 seconds, so you don't have two requests. The request will basically really take 2 seconds. You get just the important parts directly, and then it waits for the expensive part to patch over. So it will even be more
It
efficient.
also allows you to propagate defer better, right? Like
Yeah, I mean
you can actually defer from the client now. Defer, you know what I mean?
Yes, but that is a whole different thing, right?
But well, if the full name already completes, then why not ship it to the client?
Yeah, but
because then that's a whole like extra layer of complexity, and again, the client would need to be set up to deal with multiple chunks being received.
No, I'm talking about the case where you actually want to defer, because that's another problem, which is a tricky question in federation is how do you actually defer in a federated graph, because you don't have the execution layer where you can handy
they don't propagate it,
want.
and that they don't propagate
Yeah.
it. They do the defer on entities. You can only defer entities, right?
Well, unless
maybe it could just be as simple as if the
did
client,
something like this.
yeah, if the client is already saying this is what I want to defer, then the easy answer is just to be like the client takes precedence, maybe. I don't know, or maybe like there's some, winner, some spec defined winner for both
what
the
I mean
server and the
is
client.
when you can propagate the defer down to the source schema, you have a more efficient defer instead of emulating it in the gateway.
Yeah. So one other thing that occurs to me is that, again, it still seems like there's two options here. One is have the query planner send multiple requests, and the other is have it be like a defer if the source schema is available to do it. Maybe both could be could work, because if you have like synchronous services, if you've written like a Go subgraph or like a synchronous Python subgraph, like we have it Yelp, then it's not like terribly easy to actually stream responses at the moment.
But the beauty of this is, like this you got is, I would say it's maybe a day investment in the query planner. You have that in, because you don't have to plan differently. It's the same.
Right.
It's the same plan that you create. It's just that when you print this query or create this query, you kind of slice it across what is required for consecutive requests and what is actually needed later.
So if the subgraph has the capability of deferring down to the gateway, then great, use that. If not, I guess you could, if possible, like ideally fall back to sending multiple round trips, but that would then be like a change in the query plan. And I don't know if you'd want to support both, like two ways of doing the same thing. So that's just a thought.
Yeah, modern GraphQL, not the old crap.
I mean, I think that's like fair enough, right? Is just to say this is a performance optimization, that if you want this performance optimization, you have to be.
Yeah. Yeah, I at least think it. This is also like the first backend use case I have now for defer. It's always good to ask Netflix.
It looks like Mark thought of this like 2 years ago. It looks like.
It's like, honestly, it's taken a really long time to sort of like formulate the question in a way that makes sense to a lot of people. But of course, I come to you folks and you like immediately and truthfully get it because you've been living and breathing this for a while. But yeah, I don't know. So I really appreciate this talk. It sounds like the conference then is going to be pretty smooth sailing. It's going to be solved in composite schemas. Just going to wait for. So are you saying that you'd be able to like ship a change for this?
Yeah,
to happen
I
in.
probably hack that over the weekend or so.
But it's not.
Okay,
It's gonna be specifically like it's the execution layer of Fusion which works like this.
Yeah,
in
it's like we will have that in the Java implementation of this and also in the .NET.
And we just need to get defer actually like merged into the GraphQL spec.
Yeah, I have to. Did Andy already put it into Java, or is he holding back?
I'm actually not even sure because we're not using it yet.
Yeah, it could be that. I mean, it's like we implemented it in Hot Chocolate, and I had to strip it out. So it's not stripped out, but it's like the very old one which duplicates, and now I have to re-implement everything. I will ask Andy, and he probably.
Okay, so
But you guys are using GraphQL Java, or what are you using at Yelp?
we are using Strawberry. Well, we're using a combination of
Python.
Strawberry Python subgraphs
Yeah.
that are like main 90% of resolvers live in the like Node original monolith GraphQL service, which is Node, like Apollo GraphQL.js thing. And that's the one that contains a lot of the slow fields. And so the thing that I'm working on right now.
I just wanted to say, so it's not so performance critical what you have.
It's it's a path of least resistance, and anyway, but yeah, and so the monkey patching thing on top of GraphQL.js and Apollo solution that I have is probably what I'll talk about. But then I'd also very much like to say, if you don't have to do this, composite schemas kind of supports this. There are frameworks out there that support this natively, so that's kind of, I guess, how we'll talk about in Slack. It's the appropriate.
What do you use as a gateway?
This is a publicly recorded call. So I'm sure I don't know. But maybe we should talk more at the conference about
good
thoughts on this topic. Yeah.
Yeah. No worries.
Good. Let's meet up there. It's soon. It's you said 28 days, and I was like, damn, 28 days.
I have to make my talks.
Yeah, I still have to write an open telemetry specification for GraphQL.
Steven, do you have a panel, right? Do you have a panel?
Yeah, and a talk, which I still need to write my talk.
Your talks.
Because panels are like you can wing it. It's a discussion.
Your talk proposal this year were fantastic again.
Yeah.
I wanted all of them. Like do all of them.
Nice.
Just
Nice.
stage one, this is Steven's morning. Just do all of the talks.
I'll tell my boss, like, okay, I'm just gonna take off this month and write talks.
Exactly.
I'm busy. Talk about nullability.
Yeah.
OpenTelemetry is another topic near and dear to my heart. I know we got tagged on the working group meeting for that. I don't think we've attended yet. The only thing I care about is adding coordinates to the semantic conventions, which I see is I think, already a thing.
GraphQL.field.coordinate.
Yeah, it all connects, coming full circle.
I will do the OpenTelemetry spec proposal PR today, and we'll add a couple more stuff that we haven't yet discussed in the work group. But that's coming. Also, the more people that read it through, the better. Like, just give it a read. It's very, very slim because we have to specify it very slim so that you don't do bad things. But essentially, also my talk at the GraphQL Conf will boil down to cardinality. That's the main issue. And we can. I actually want to change the talk title. I think /GraphQL. The talk title monitoring GraphQL : /GraphQL the /GraphQL problem would be such a nice name for it, because whenever you use a GraphQL server and you add it, you add telemetry to it, the only thing that you ever see in the telemetry is /GraphQL. It's
Yeah, so I have an issue with the spec there, and I did propose that it could use like I think most folks are using like document hashes or something like that, and having that be
You're still
in
sharing
the name.
Yeah. I was just checking out if ChatGPT 5 is out.
Sorry, Mark. I was distracted.
Yeah, if I was sort of like evil emperor of OpenTelemetry and GraphQL, I'd probably make the span name include the hash of the documents, because anything else is pretty much wrong whenever people try and use like the query name as the unique identifier. That's not unique because
okay. So where we landed on is that you should, if you don't use persistent operations, if you don't use trusted documents, and if you can, you should, then
there should be like just two different spec conventions there for persistent versus not
it
persistent.
just says that when you don't use trusted documents, you should not put neither hash, operation name, or anything else into your GraphQL return. If you use trusted document, the recommendation is to put in the operation name, because the hash actually will be an attribute on it. And with the operation name, you have a way to actually find the thing, because you can open the UI repository, you can open it in VS Code, you can search for the operation name, and you immediately find where it is. Whereas with the hash, you have this intermediate step, where you have to jump around.
But the operation name isn't unique though, right?
Yes, it isn't, but it often is.
It's also about semantics, right?
It depends. It depends how the backend aggregates it, right? I mean, your OpenTelemetry system aggregates it. If it's GraphQL aware, then it could aggregate it based on the hash, but you don't need to necessarily aggregate the traces based on the span name. But in the normal case, I would say it's fair enough to aggregate.
But it's also, I would have both, right? The hash and the operation name. Do you know, like the way you do with, or we call them semantic routes, where you have the persistent operation in the route, and that like Twitter does, for instance, you have the hash and then / the operation name, and then it's unique, and you get also the semantics of
that's a good idea. That's a good idea anyway. But also there, what you have to, for a telemetry system, you shouldn't do this. It's very easy to identify the request with the operation name in the browser and maybe on Cloudflare and wherever. But in the telemetry system, you immediately would cause a cardinality attack, right? Because you can just GraphQL / 1, 2, 3, 4, 5. You can send a billion requests, and then the telemetry system is essentially overloaded with a cardinality explosion.
Oh, if you're not using persisted documents, you're saying.
Well, it's like what Michael suggested, that you have essentially you have named queries, right? So you essentially say that the route that you send your request to is not /GraphQL. The route that you send your request to is /GraphQL, and then the hash, and then the operation name. And this is Twitter does this, for example. It's a very common practice. It's super nice for UI developers because, or for looking in the UI in the network tab, because you don't have 15 requests to /GraphQL. You actually know, okay, I fetch the user, so I can search for the user, the user query there. So that's super nice, but it doesn't solve the telemetry problem, because you would still have, if you don't have slugs in the URL in your traces, so /GraphQL, curly brackets, ... whatever. If you don't aggregate based on this, then you immediately can be attacked with
you kind of have these, like, right? This could be the hash, and then you still have here the semantics of what this is. The nice thing is also with the routes that you kind of get here what's the semantic of the request, and then this is the unique part, which makes it unique. This is a version of this kind of request.
My strongly held but deeply unpopular opinion is that including the name of the query in any telemetry or logs is sort of like an anti-pattern, because people then go and copy and paste that query name and search for it in code and be like, oh, this is the query that's being executed, right? But that's not always correct, because it could be an older query, like a mobile client could be sending a query that's like outdated and you've like since changed the query but kept the query name. And so like it's updated in code and in your allow list and whatever, but like it's a different query altogether. Or maybe you're not guaranteeing query name uniqueness across your whole, company, and like the Android app has like, get foo, but like the mobile, the iOS app also has like get foo, and it's like the same query, but with the same name of the query, but like different queries. Versus the query hash, like, is the absolute unique guaranteed this is the correct thing. But like, that's, if you're going to copy and paste anything, copy and paste the hash, right?
Yeah, but that's about, so this is what makes it unique, right? That's the thing. But this gives you the topic. What is this thing about?
The hash,
that's what people
might not appear in code anywhere, like in your in your Git repo. The hash is maybe only like in the persisted database.
So we have like we've trained people really well to recognize this is document hash, like go to this internal dashboard, paste it in, like you can look it up. Any like Grafana dashboards or anything like that have like the magic hyperlink in, so that when you see the document hash, it's actually a hyperlink, and when you click it, it takes you to the thing. So I agree, like it's a bit of a pain in the ass to see just the document hash, but like it just removes a whole class of foot gun. Like, yes, it's like a little bit more, you gotta kind of find it, whatever, boohoo, but it just, I don't know, reduces a whole class of people going down the wrong path.
But one advantage of having the operation name as a dimension in your, like in our metric system, it's, I guess, closest to like Grafana or something. It's called Alice. We have the operation name and the hash as dimensions.
Yeah.
And sometimes you want to dimension by the hash, sometimes by the operation name for, for different cases, like, because for the operation name, common case is for, an older client, we've got, 100 different hashes that are the same operation name because it's just different, like different releases,
versions,
build.
Yeah.
But, in most cases, maybe we wanted to just group those together, see them all aggregated because they're roughly the same thing. But then we see, maybe there's like, errors with a certain build, then it's nice to look, drill down to the hash and see, okay, it's just this specific version.
that's why I say you need both. Like this
Yeah.
is kind of like if Twitter, for instance, releases here a new thing, like this is still the home last timeline request that you have, but you suddenly see that the new hash is performing much poorer now. And that's maybe because you included the slow field and the query planning is off. and and that's why it's a good thing. It's not unique this query, but it's like this
but
this logical query.
the only way how you can correlate these is based on the operation name.
Yes,
Because
that's why I say you need both things here. This and this.
Yeah, no, I'm saying that the problem is like I've never thought about it this way, but technically it's probably a good practice to make sure that your operation name across, like you don't share operation names.
Right. That's the problem that we have, is that even within a monorepo, it can be hard to do that. But certainly across like whole different platforms, I mean, you can enforce it. It's just like not an out of the box thing by
Something
a
that we could
manifest or
actually
whatever.
micro, actually.
But yeah, if your company is already set up with every query name is unique, then you sidestep the problem, or at the very least, it's namespace. So our guidance is you can use a hash, or you can use like a fully qualified query name, which would be like repository that it's in, or like you like namespace it with the like platform. And then if you have both of those things, then okay, it doesn't account for like previous versions of the query, but it's going to be that, some version of that query. Yeah. But I mean, for the purposes of like having it as a span tag, like, of course, it should be a span tag. Yeah.
Yeah.
I sent you the link. I just did the pull request. I did stashed locally, so I have to review it once. But that's the initial thing. Now, what's next is we're going to talk about a lot of other things that we want to put in there. At the moment, you only care about tracing, then and only about GraphQL normal request tracing. Then additionally, what will come, well, I will already make a proposal is for data loader batching because that's quite useful to know as well. Then after that, we are probably in the realm of talking about distributed GraphQL, although this is a bit of a specific one. But you need to know how long, like we need special spans for how long did the query planning take and so on, as we have the same thing for the document validation and the parsing and variable correlation and so on. And once we have specified all the tracing, then there's metrics. And what's still a big unknown is errors, because what we had there's someone joined from Trask. Actually, I know his name. Trask joined from Microsoft. He's part of the specification team on the OpenTelemetry side, which is super nice to actually have someone on board which knows this by heart. And he told us that at the moment the errors, the exception logging will shift a bit. So they're no longer, in the future, they will no longer be added as events on spans, but they will actually be used as events, as log events. So that's going to be one thing that we have to think about, like how do we indicate what errors did the resolver have? Is this really an OpenTelemetry exception, or is it not, because it doesn't really have a stack trace and all these things?
Yeah, I think about that as well. And like one thing that we found helpful is to remind people that aren't familiar with GraphQL, in that errors don't always equal 5xx's, as is the case for like non-GraphQL services. That like bulk endpoints, batch endpoints exist in REST as well. And so you might theoretically have like an error for 1 out of n businesses you're trying to return, but like you still want to return 200 with the rest of the items in the batch. And it's kind of like the same thing for GraphQL. Yeah.
Yeah. So we took the main working group and then we extended it by half an hour. That's fantastic.
It's now about composite schema, about OpenTelemetry.
I will rename the repository now.
We put it all in one.
Yeah, composite schema working group 2.
Good discussion there. It's interesting.
Yeah, that's really good.
I mean, we've now discussed Mark's conference talk. We've discussed my conference talk. Do you guys also have topics that you want to discuss to prepare for the conference?
I think I'm
Awesome.
probably gonna head off now. But yeah, thanks so much, everyone.
Let's stop it here. Guys, see you next time.
See you next time. Bye bye.